All right, guys, welcome back. And today, I promise you, I'm going to show you a project that you've never seen before done with a CNC. So that's what we're going to be working on. My wife wants kind of an insert to go inside this massive pot that will allow her to put smaller plants in smaller containers in it, giving the appearance of a larger container, but still having the portability and being able to take things out of it without having to fill up this massive container full of dirt. And she asked me if I thought I could make something to do this. And so, naturally, I said I could. So that's what we're going to do today. And we're going to be using plastic on a CNC. So stick around. I'm going to show you how to cut plastic with a CNC and make that. Let's get started. All right, so if you're not familiar, guys, this is my large CNC. This is the CNC that I bought for use in my shop. It's the Shapeoko 5 Pro. I do have the 1.5 kW spindle on it. It's the air-cooled version, and I love this thing. So today, what we're gonna do is take some material and create this step in here for this flower pot, but we've kind of got a unique situation. Normally, I do a lot of stuff with wood, MDF, you know, that kind of thing. But this is going in a flower pot. Flower pots are going to be wet. They're going to be outdoors. They're going to get watered. So the material to do this job with needs to be a material that can handle getting wet and not destroying itself by absorbing moisture. MDF is definitely a no-go. The moment that the stuff gets wet, it just falls apart, starts, you know, just turning back into sawdust. Plywood and regular hardwoods, I could probably get away with for a couple of years, maybe, you know, depending on the weather and how wet it did actually get. But to me, in order to make this project and not have to remake this project next year, I decided I wanted to use some plastic. Now, luckily for me, I have some thicker plastic material that I've got from a local company. They have scraps and cutoffs and stuff that they throw away. And I've managed to get myself a few small pieces of that. Unfortunately, they're not as big as I need, but I've come up with a way in my head. I've designed it and got it going, and I think this is going to be a workable project. So this is the material that I've got, guys, and don't ask me exactly what it is. I don't know. Like I said, this was some little cut-off scrap pieces that I was able to collect that were going into a recycling bin. And it's plastic. It's very hardy, very thick, and so I feel like this material will do the job. Now, the only problem is this is the size of my container, and this is the size of my material. And you would think that that would be an issue because, you know, it's not going to be able to, I'm not going to be able to completely fill the container. But you got to keep in mind, this needs to set down lower than the pot. So that is going to give me a little bit of an advantage as far as when it goes down in there, it's going to get narrower. But also, that's going to give me a way to be able to reach in and pick this thing out from the way that I've got it designed in my head. Now, to assist in the process, this is why I say I use a lot of different tools, and to me, lasers, 3D printers, CNCs, they're all just a tool that has its place. During the design process of this, keep in mind, I have two pieces of this material, and even though I didn't purchase it, it's probably an expensive material if I had to go buy some more. So I wanted to make sure that I got this correct the first time. And so I used the laser and some of my 1/4 inch material to create basically a simulation of what this needed to look like to go in here. And so that's what I ended up doing was I took the laser and decided how deep in here I needed to go, and I cut this little guy here and made it to where it would sit in here in a manner to where I felt like, you know, that would work. That would give me a little bit of a lift. Here's the catch. In the event that it needs to come up higher, let's say Brandy decides that she needs it to be taller, adding a few bricks to the equation will help weight this down to keep it from flipping over, as well as it'll give you a couple more inches of elevation. So I felt like that was going to be the circular shape or circular size that I needed. So I used this here to design and move forward, because now I've got how big I need to make this, and I've got it set to where the depth is where I want it. And so I'm just going to move forward. So I use the laser to create this, just more or less for templating and figuring out how I wanted to move forward after we got this measurement calculated. So the next part of the process was to confirm that my material was going to be large enough to house the design that I had, came up with in my head. And so indeed, the material is large enough. It is going to have some openings, of course, on the side. But like I said, I think that's a good thing. It's going to allow the water and airflow through there. So maybe it don't like start growing, gunk or whatever inside there, as well as it's going to afford you a place to be able to lift it up and down. And I could even, if I needed to, use this shape to go about cutting, some little circular pieces to sit on top of it that would be disposable in the long run. So I got that part figured out, and the next part was to set the file up so that I could go from idea, concept, material size over to the CNC and create the physical product. So the next step was going to be file design. So we're going to move over to the computer now, and I'm going to walk you through the file design and how I set this up using that little picture of how I thought it needed to work in my head. So let's jump over into Vectric. We're going to be using Vectric VCarve Pro today for this project. I do have Aspire, but sometimes I like to switch back and forth just to show you guys that a lot of the things that I do in Aspire, you can do in the other lesser versions as well, especially something like this with just simple cutout and a pocket. So let's get over there and look at it. All right, so if you're familiar with using Vectric, I apologize, but I'm trying to make sure I kind of point out a lot of the design aspects of this to folks that maybe are new to design in Vectric. So the first thing that you'll notice here is over here to the left side of the screen, this is the measurements. This is the actual measurements of my material size. And the reason that that's important with this design is I want to make sure the design fits on the material, and I've got an idea of how it's going to look. And like I said, in this design, it's going to overlap here to where you don't, like there's not going to be any material in this area or this area. And that's fine. For what I'm trying to accomplish here, I don't need those areas to be filled. So this will more than adequately work. The material that I've got is 475 by 270, and it's just under 19 millimeters thick. So I've got that set at 18.9. I will be running my 0 on my machine off of the machine bed. And I've gotten to where I like running off the machine bed more than the material surface lately. And mostly because if you ever do have to go back and try to correct a design, it's a lot easier when your reference point as far as your 0 is off the machine bed as opposed to the surface of the material, because there are times that you're going to remove material from the top and change the thickness and so forth. So I've gotten in a habit of running machine bed a lot more often. For this project, because this is a circular project, and like I said, it is smaller than my material, and I want it centered in the material best I can, I'm going to be running my XY coordinates as a center point instead of the corner. And that's just so that I can make sure I'm getting the most out of this piece of material and I'm not off to one side or the other. It just makes alignment a little simpler. The material settings, I'm going to use this pale blue plastic setting because there's not a white plastic setting. And we're going to set this up. The outer cut right here is 420 millimeter circle is what I'm going with. And what I did is I took a ruler, put over in the bucket, and just decided how deep, or the flower pot I guess, how deep I needed it to go, and measured the size there as far as the circular area needed. That didn't have to be exact. I just wanted it close. And then once I cut this part here out with the laser, I took that and set it in the bucket. And that's how I decided how tall to make the pedestal. Because you'll notice here, I've got these other two lines. And this is for the pedestal that is going to keep this thing from pushing down towards the bottom of the flower pot. Now, maybe I could have just went with the circular shape, even though I didn't have a complete circle, because keep in mind, these pieces are not going to be there. Maybe that would have just sat there. It would have sat straight. It wouldn't have had any problems. But I feel like a support in the center is a good idea. So what I ended up doing is I've created this pocket. I found some 3-inch inner diameter thick wall sewer pipe that I had here in the shop. And I'm going to use a small piece of it as kind of a center leg for this design. And so this pocket here has been created to allow room for that leg. So let me go over here. I'm going to just run through real quick and show you the preview so you'll get an idea of what I'm making. And then we'll go through kind of the steps. So you can see there, that's just a recess. And I think I went with 6 millimeters deep for that recess. If you look right here, the pipe pocket, I wound up going 8 millimeters deep. And what I did is I measured the inner and outer diameter of the pipe and just basically created a pocket where the pipe can slide down in there. And then we're going to attach everything that way. I will be using a genie bit, a O-Flute end mill. I'm going to run the 1/8 inch O-Flute with this job, just because I know a lot of you guys, or maybe you don't have a big enough machine that you want to run the 1/4 inch bits or whatever. I know Cody just recently released the O-Flute 1/8 inch, and so that's what I'll be using. And I will put a link to this bit in the description as well if you're interested in that. As far as the cut goes, same thing. I'm going to be running the O-Flute end mill, the 1/8 inch genie bit, with plastics and stuff like that. This machine can scream. I'm being real conservative with my settings and speeds and feeds. Again, I am not trying to win a race. I'm not in a hurry. I don't want to break bits or take a chance on messing up my material by going too hard and too fast. The more aggressive your speeds and feeds, the better off your work holding needs to be. And in this particular job, you'll see the work holding is going to be a bit sketchy because of the way my material sits. So that's where we're at. So we're going to move over to the CNC. I want to set the next piece of material up, and we're going to run this file and show you how we cut it out. All right, so as you can see, guys, with my Shapeoko, I have used the machine and cut these little holes here for these little dogs that I've 3D printed. And I use those to be able to jig out or help with work holding with material. And so I'm going to take this piece of material and I'm going to slide it over here against this side and up against these. The way I'm running the 0 is going to be off the center of the material. And you'll see the pencil lines here. Those pencil lines are just to show me where the center of the material is so that I can set the 0 accurately there. These clamps, these are some of the essential clamps that Carbide, they have the download file on their website. If you go to Carbide 3D, they have a whole section of things, parts, add-ons, tools for your CNC that you can download and 3D print yourself. I do have these clamps in black, green, as well as the ones we're using today, which are orange. The cool thing about using 3D printed clamps is unless you hit this steel bolt that goes in it to hold it in place, the clamp itself will not hurt your bits because it's a soft plastic, and it also is easily to be replaced simply by just printing some more. And so what we're doing now is just putting some good hold down on this material so as to not get the clamps in the way. Like I said, this is kind of a special case as far as work holding goes, because one of my clamps is actually going to be, or two of my clamps are actually going to be inside the area that we're cutting out. So I'm going to show you that in just a second. Let me get this last clamp tightened down. And like I said, you don't have to go crazy with these. This plastic cuts like butter. I do like to make sure they're nice and snug, but nothing too extreme. These are 3D printed clamps, so you don't want to go too crazy. I print them with PETG typically, so they're pretty sturdy, but you can't snap them if you over tighten it. So with this clamp and this clamp are going to be inside the area to be cut, and they're going to be holding the material inside there. But I've also got tabs connecting the outside pieces to the piece that's going to be cut out as well. So it's kind of a weird work holding situation. It gets a little sketchy when the bit's going between clamps. But if you recall, earlier we made this template to use to size the cut with. We can take this template, and I can also kind of show here by using this little template, I can kind of line up and show you where the bit is going to go. And it's going to go outside of the clamps. So even though it's a little scary looking, we're going to be good. So it's going to go outside of the clamps. So I'm going to go ahead and set this up. Another thing that I do like about my machine, and this is not necessarily unique to the Shapeoko, but it is a cool feature, is I have the bit setter over here that helps me keep track of the Z-axis. It just makes it a little easier between bit changes to adjust the machine, but I also have the ability to move the machine with the controller. This is just a standard Xbox controller that you get on Amazon. Takes, I think, AAA, AA batteries, and so you can use it to operate your machine to set the zero. And that's what we're going to do next. Is I'm going to take the controller and we're going to move the machine out and bring it down to line up the X and the Y, and of course the Z axis is going to be the bed. I've already run one of these, so the Z is technically already set, but we'll go ahead and show you how it's done. So with the X and Y, what I want to do is I'm going to run that bit down there until I get it close enough to the material to where I can just ease it over. Then I want to put it right on that line that I created on the material and get it as close to the center as possible. Now, once I get that, I go into the software over here. I'm going to go to set 0, and I'm going to 0 the X, and I'm going to 0 the Y, and I'm done with that. So then I can bring it back down over the spool board here, and with this machine I also have my little probe here, so I can set the probe up below the bit, and I'm going to go over here to probe in carbide motion, and I'm going to tell it to probe the Z-axis and hit the button. It's going to confirm begin probe. I'm going to confirm that. The machine will come down. It's going to touch this probe, this little block, and it's going to go back up, and now the Z-axis is also set. So I'm good to go. The final part that I need to do is with mine, I've got this, I guess, pro version of the dust boot. So I'm going to move it down to where it's almost touching the material. For this job, I don't need it to be too far down. I want to leave a little bit of an air gap. The more of an air gap you can get below there, the better your dust collection is going to work. And so once I've got that done, we're good to go. I do like to raise the bit up a little bit before I hit the start, just out of habit from other machines. But I'm going to load the file in to the machine now. And this is going to be my flower pot stand G code. And we're good to go. So now we're just going to hit start job. Hit start again. Then the bit's going to go over. It's going to confirm the Z. And once it confirms the Z, we're off to the races. All right, so it's telling me to change the bit, insert bit number 16. This is my little O Flute 1/8 inch, which is the one I've got listed as 16. So we're good to go. And here we go. Off to the races it's going to take. The machine's going to go down. It's going to confirm the length of the bit using the bit setter. Once it does that, it's going to, if there were any changes to the Z-axis, this is where the computer would automatically affect those changes to the setup. Since there is none, it's just ready to go run the file. So it's going to come over. It's going to go to the 0 point first. Then the spindle is going to cut on. Once the spindle cuts on, we're off to the races. All right, so the machine returns back to the 0 and then it is finished. So the machine is completely done, and now all we've got to do is get our workpiece off of the table. Now this is, like I said, this is one of those jobs, I bet you've never seen this one done, and you bet you have seen it done. It wasn't done exactly this way. And a lot of people ask me, you know, why would you do this? You could just do this with whatever saw or whatever. Yeah, I could, and I could do it with a bandsaw. I've got one sitting over here. But this is accurate. This is the way that, I mean, this is just, it's a good way to make parts and make them completely repeatable. And so if you have a CNC and you don't have one of these little oscillating saws, they're really handy for tabs. You can go as fast or as slow as you want with this power button on this thing. And this material cuts really smooth. Like, it cuts like butter. It's nice. It's supposedly UV resistant, weather resistant. They use it in boats, like in manufacturing parts for boats. So you can see here, we've got our insert there, the rounded shape here, but I've got hand holes here that I can use to put this in and take this out. So let's move over to the table and we'll finish designing this thing. All right, so again, guys, in case you missed it, there's our little circle. And I took the PVC, this is 3-inch PVC, and if you're not familiar with it or if you've never used it, you can cut this stuff. It cuts really nicely on a chop saw. The only thing I will caution you is go slow, let the blade cut, don't force it, and keep your fingers out of the way. But this stuff cuts really good with a chop saw in your shop if you're using it for whatever you're using it for. And so this is cut to the right length, and I also got this hole machined to where this fits in here. So this is going to be the foot that holds it in place. But the only thing is if I turn this over like that, it can fall out. But we're going to address that in just a minute. Before we move forward, I do want to show you guys, this is going to sit, and you can see it in the overhead camera, it's going to sit in the flower pot kind of like this. Now the reason I wanted the little piece on the bottom is because if you push hard on one side or the other, you know, this thing's not, it could move a little more. So I kind of like to have 1, 2, 3 points of contact with this. And so by having this underneath here in this little recess and then putting it in the bottom, it's kind of hard to get it lined up like that. So we definitely need this attached to here. So we'll show you how I'm going to go about doing that also, because I got a trick for you on attaching this plastic without using glue, because I don't want to use glue. This is a simple little operation. I want to keep it simple. I don't want a bunch of toxic fumes off of a material. I'm not sure exactly what it is. So we're gonna make this stay together without using any kind of chemical glues. So let's get it done. All right, so if you saw many of my videos, you probably saw me use these. These are high-speed wood dowels is what I like to call them. Some folks just call them wooden skewers. Yeah, you can get them in the grilling section at most of your grocery, hardware, big box stores. It's just literally, it's a skewer for a shish kebab. So I use those in the shop a lot for aligning multi-layered CNC files, laser files, whatever the case may be. They're just really cheap, easy to use, and easy to deal with. So we're going to be using that to hold this together. Let me show you how it works. So what I'm going to do is these lines that I drew to find my center are now going to act as alignment points for me to drill a hole. And I'm just going to drill a hole at about a 45-degree angle. This doesn't have to be rocket science, but I want to drill those holes through the PVC as well as this material, and I want to go all the way up in there a little deeper. And as you can see, once I drill the hole and I stick my high-speed dowel, I'm going to snap it, but I'm not going to break it all the way off. It's about that deep. So that's going to help hold this thing in place. I'm going to snap that dowel off in the hole, and then we're going to move to the next one. Like I said, this is not load bearing. This is simply to hold this thing together until I can get it put in place And once I get it in there and get it put in place, the pressure is going to be downward. And so there's no pressure going to be on my little dowels here. These are simply to hold this thing in place while I get it inside and get it set up in there. So take those guys, put them in those holes that I just drilled. And like I said, that's going to hold everything together. And then the last step is I'm going to take my little high-speed Gorilla hot glue gun there, and I'm just going to use a little bit of hot glue to hold those dowels in place. And so what I'll do is I'll put hot glue on all 4 of those, and you can see now this is not coming off of there. Like I said, the purpose of the little dowel pins is just to hold these 2 pieces together so I can flip it over and put it inside here. You could use screws if you wanted. You could use whatever. To me, for what I'm doing, this is the cheapest way to go. It's 1 shish kebab stick. We'll do 2 of these. All right, so my little hot glue gun has gotten warm. And so all I'm gonna do is I'm gonna press a little hot glue on top of where the wood dowels are. Like I said, really the only purpose of the hot glue is just to hold my pins in so that this thing just stays together. But if I do decide that I want to take this apart, let's say we decide to put them up, or whatever the case may be, it wouldn't be all that difficult to pop this hot glue loose, pull those little dowel pins out, and go from there. So once that cools down, we're good to go. All right, a few minutes later, guys, and everything's cooled down, and you'll see, like I said, those little dots of hot glue are holding those pins in. And with the pins in there, even though they're just basically oversized toothpicks, they more than adequately hold this together so that you can place it inside of here without worrying about it falling off or whatever. And another thing is, like I said, when you put weight on here, that's going to keep this thing from cupping and bowing and trying to push down into the pot. I don't know exactly what this thing's made out of. It feels like some kind of foam. So it's not real heavy. That's why you see me handling it like that. It looks like concrete, and that's what Brandy likes about it, is it has that concrete look, but it's not. Like, it's literally, even with my little piece I just made, I can lift it one-handed with my bad wrist. So I don't want to put too much pressure on the walls pushing outward. So by having this little foot down here, that's going to help distribute the weight towards the bottom the way that it was intended. But it's also going to act as a spacer. You've got plenty of room right here for your hand. When you put it in there, if you want to take it out, you can just pull it out. Like I said, I've got the little foot on there, and then this comes down and sits in there like that. So with this, like I said, you could come and if you wanted to add layers to this, or if you wanted to put a floor in it, a little more solid of a floor, you could literally just cut yourself some 1/4-inch plywood like that to put in here to kind of hold everything. And then the cool thing is this could even rot away after a while, and it would be easy to replace just with a piece of this material. But it's not tight fitting. This isn't structurally dependent on this. Like I said, if I had bigger pieces of the plastic, I would have loved to have had a full piece of plastic all the way around there. But being that these are the pieces that I had, this is what I worked with. Like I said, you could put that in there. If I had more pieces, and maybe I get some more someday, I could, put some more this way. So there's lots of different options, but now I have both of Brandy's little flower pots. I have these bases made that will allow her to now sit bricks in here, put bigger pots, put a fern, whatever she wants to put in here, without having to fill this thing completely full of dirt. And it also allows her to be able to move them without having to have a forklift, because this full of topsoil would be very heavy. Trust me, we've got a couple of them already. So there you go, guys. Weird project for the day. All right. So I hope I didn't disappoint when I said I was going to show you a project that you'd never seen before. A lot of folks will tell me that, oh, you overcomplicated that. You should have just piled bricks in the bottom of it. I get it, guys. Some folks might consider this to be too much work. It might be too much hassle. You don't want to go through that. But for me, solving problems is half the fun. I enjoy making, but solving the problems, developing this, inventing this in my mind before I even look to see, you know, whether it'll work or not. That's the process that is the most fun to me. So let me know what you think down below. I know I'm going to get a lot of folks telling me how I, you know, way too many tools to do such a simple thing, all that, overcomplicated it, could have done it with just piling bricks in there. You know, I can hear the comments now. But the moral of the story is I had fun doing this project. I enjoy things that make me think, okay, I've got these materials. I need to solve this problem. How can I take these materials that I already have and solve this problem? To me, that's part of the fun. That is the reason I got into doing stuff like this. And whether you guys all like it or not, I'm sorry, but I enjoy it. And the content that I make here typically are things that I enjoy. So I hope you too enjoyed this. And if you did, be sure to subscribe, follow, like, share, all of those cool things, because I do sometimes, you know, need an extra follow or two or an extra subscriber, because you're full time out here now. I am retired. My little harebrained ideas like this are going to be coming more and more frequently, and you never know what you're going to get. So let me know, are these random, weird, off-the-wall videos, are those something you're interested in, or should I just stick to the old cutting boards and charcuterie boards type stuff? I mean, should I just stick with that? But anyway, guys, this was a fun little project. Like I said, Brandy asked for it. I wanted to make it look professional without having to spend a fortune. So other than some of my time, and I actually cleaned up some of my material and gained some space in my shop. So I think that's a win in my opinion. But I will drop a link also to the Shapeoko 5 Pro down below. If you're interested in the CNC, the bit, just go check those links out and follow up on that. 4-inch PVC, you can get it at most of the big box stores. This material, I don't know what to tell you guys. It's plastic, okay? But it cuts like butter with the Genie's O-Flute, 1/8-inch O-Flute bit. So it's a good material. I'm gonna try to get some more of it. But yeah, one more project down and off the honey-do list. So till next time, guys, be safe. Have a good day.